Good afternoon, guys. I know that we've been going backwards here, but today we're wrapping up with the solving quadratics skills. We know how to solve quadratics by graphing. By factoring. We know how to solve quadratics by completing the square. And today we're going to learn how to use a quadratic formula. Using a quadratic formula allows you to solve any kind of quadratic equation or function. That's the beautiful thing. This can be used for the simplest of quadratic equations or the most complex. You got decimals and fractions, you use the quadratic formula. You got pretty nice numbers, maybe completing the square, maybe you can even factor it. But regardless, you can use the quadratic formula for everything. I do not suggest you use a quadratic formula for everything on your tests or quizzes because you will not have time. But on an SAT or an ACT or in a real life application, in a pinch, oh man, I forgot how to factor. Oh yeah, let me just use the quadratic formula. That will give you your solutions. So in fact, you can use the determinant also. Not the determinate, but the determinant. And I'll get to that in a second. Okay? So not only can you use this to solve any equation, but in fact, you can use the determinant, which I will tell you in a little bit, from the quadratic equation to find out how many solutions you will have before even solving the equation. Now, in order to solve any quadratic equation, ax squared plus bx plus c equals 0, use the quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Remember this, guys. We're looking for x values. Just to remind you, what the heck are we solving for? When I have an equation that's a parabola, aren't these x-intercepts? Because that's my x-axis and y-axis. And aren't those x-intercepts? Those are the solutions. Those are the answers you get from doing this. Or from when you're factoring. Remember when we have answers like x equals 5 and 7? Or negative 5 and 2? That would be my negative 5, that would be my 2. These are solutions. The solutions of a quadratic equation are basically the x-intercepts. It is the points on the x-axis that the graph intersects. So that's what we're solving for, these two green points right here. Does that make sense? Okay. So now, let's use it, because it's pretty simple. What are the solutions of? Okay, I want to tell you right now, I don't know if the book left it in square root form or if they use a calculator. We do not use calculators, so we are going to keep it in square root form. First things first, you always have to put it in trinomial form. Ax squared plus bx plus c. So the first thing you're going to do is subtract 4 to both sides. So I've got 2x squared minus x minus 4. You don't have to do this, but it helps, especially at the beginning. A is 2. B, bless you, is negative 1. And C is negative 4. I don't do that anymore because I've done a lot of these. But I suggest you do it just until you get the hang of it. So now, remember the formula. It's negative b plus or minus the square root of b squared minus 4ac divided by 2a. So now it's just plug and chug. So negative times a negative b, so we've got 1 plus or minus the square root of negative 1 squared minus 4 times a times c divided by 2a. So I've got 1 plus or minus the square root of, that's 16, 32, 32 plus 1 is 33, and 2 times 2, that's 4. Done. Yes, sir. So that means, okay, just so you understand, I'm going to cheat here, just so you can understand what this is giving you. When you have, I'm going to put in, so I've got square root of 33 plus 1 divided by 4. So one of my answers is 1.69. And then 1 minus equals divided by 4, and it's also going to equal negative 1.19. So just so you understand, you have a graph that's going through 1.69 and negative 1.19. That's what those told you. That just told you, hey dude, this graph goes through this point and that point. That's the power of this. Yes? Since we don't use calculators, you leave it like this. I did not give you these answers to encourage you to use calculators. I gave you those answers so you could see what it is that we're solving for. Sir. Yeah. Yes, sir. Huh? How do I solve what? I use a calculator. 1 plus the square root of 33 divided by 4, and then 1 minus the square root of 3 divided by 44. Thank you for asking, sir. Divided by 4. Thank you for asking, sir. Okay, let's do another one. X squared plus 6x plus 9. It's already in trinomial form. So, negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a, which is 1. So it's going to be negative 6 plus or minus 36 minus 36 is square root of 0 over 2. So that means it's negative 6 plus or minus 0 doesn't count over 2. So this is negative 3. So x equals negative 3. So in this particular case, this is a parabola that just goes through one point. So it's going to look like that. It only touches at one point when x is negative 3. That's the only solution. It's a perfect square. That's exactly right. Good man. Yes, sir.
For example, 8 is x equal
Of course, x equals this. Yes. Of course, x equals that quadratic formula. What did we just talk about, bro? We talked about that these equal the x-intercepts. Are you sure? I put it right here, my man. I apologize. X equals. Thank you, sir. Yes, sir. Yes, you need to memorize the quadratic formula, sir. 100%. Now, add 4 to both sides. X squared plus 4x plus 4. So negative b plus or minus the square root of b squared minus 4 times a. Look at that, times c. You're going to get another 0 in here. Divided by 2a. So this would be negative 4 plus or minus 0 over 2. So negative 4 over 2. Again, it's going to be a perfect square. X equals negative 2. Next. Negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 3, over 2 times a. So that's going to equal negative 4 plus or minus 16 plus 12 is 28 over 2. Now pay attention, guys. Square root of 28, doesn't that break up into the square root of 4 times the square root of 7? So this is where your skills come in. Negative 4 plus or minus 2 radical 7 divided by 2. You can divide 2 to this and to that. So in the end, I get negative 2 plus or minus square root of 7. And yes, so we don't get confused, that equals x. It's actually quite simple, guys. It's just memorizing a formula and knowing how to do your math. And knowing how to simplify radicals. Yes, sir. Yes, we will have a quiz on 4.6 and 4.7 tomorrow. Are there any real questions that are pertaining to the lesson? Or do you want to know when the final exam is already? Okay. Next. So what is so special about this discriminant thing that I told you about? Well, the discriminant of a quadratic equation or function, okay, in the form of ax squared plus bx plus c equals 0, is the value of the expression b squared minus 4ac. The inside part here, this inside part is called a discriminant. Now, what's the purpose? What's the point? Who cares? There's a lot of awesomeness here, guys. Check it out. Remember how I told you that we're looking for x-intercepts? Those are my solutions. Guys? Okay. Now, let's check it out. When the discriminant b squared minus 4ac, when it equals 0, when the inside is 0, you're only going to have one real solution. So it's going to look like something like that, where it only hits the x-axis at one point. So if I know that the discriminant is 0, I know I have at least one solution. If my b squared minus 4ac is greater than 0, it's just a positive number, you're going to have two real solutions. So you'll have, for example, two different solutions, two x-intercepts. These are just examples that you can look at later on your own. When b squared minus 4ac is less than 0, when it equals a negative number, there is no solution. It never touches the x-axis, as you can see. Never touches the x-axis. Okay? And last but not least, and one more thing that's kind of interesting. If b squared minus 4ac turns out to be a perfect square, there are two roots, really, but only one. I'm sorry, no. When we have a different squares, we're going to have two different answers. So we're going to have plus or minus 5. So for example, if I say x squared equals 25, and I take the square root of that, x equals plus or minus 5, you're having your two different roots. Okay, so if it's positive, I have two answers. If the discriminant is 0, I have one answer. If the discriminant is negative, there's no solution. For example, okay, you could do the whole entire setup, or they just want to know the number of real solutions. So, okay, check it out. B squared minus 4 times A times C. Isn't that going to be a negative number? So right off the bat, I'm not even going to go any further. That's no solution. Real quick, x squared minus 6x plus 5. You got b squared minus 5. Could you bring it over? Thank you. B squared minus 4 times A times C. That's going to be 36 plus 20. That's 56. So that's a positive answer. So I've got two solutions. Now, you may say to yourself, why does that help you? How does that help you? Let's say you're doing the quadratic formula, and you realize that you get a negative answer. Would you continue? No, because it's going to be a no solution. Okay, guys? Homework is valid. Quiz tomorrow on 4647. Thank you very much. God bless you all. Have a wonderful day.